Hey guys, welcome to our chemistry video, and today we're going to be talking about hydrocarbons. So, hydrocarbons are basically a combination of carbons and hydrogens, and as you can see over here, we have three different hydrocarbons. We have methane, CH4, which is a natural gas found in the atmosphere. We have ethane, C2H6, and we also have propane, C3H8. Let me make that look like an 8. So we've seen propane in our everyday barbecues and all of that. And because of this, we can see how common hydrocarbons are in the world and how much we really need them. So I'm sure, as you've seen the thumbnail of this video, it is actually an oil refinery. And basically, there's lots of forms of oil and lubricants and many other stuff such as asphalt, jet oil, a lot of liquid or a lot of stuff that we use in our world as fuel are hydrocarbons. And this comes to show how important hydrocarbons are. And because of this, we should probably learn about it and see what makes them so useful in society. So over here, we can see the chemical formulas CH4, C2H6, C3H8. And you can see an increase of CH2 in every increase of in every addition of a carbon, we get two more hydrogens. And if you really wanted to, there is actually a rule that you can set. So basically, number of hydrogen molecules, so number of H's, I'm going to draw that, equals 2 times number of carbons, so C's for carbons, plus 2. So if we use this rule, we have one carbon over here. So 2 times 1 plus 2 is 4. And over here, we can see that we got the right answer. And you can use this formula to find out how many hydrogens you need with the amount of carbons you have. And obviously, this formula will not always work because there are definitely exceptions to this rule. And different types of structures you can have with hydrocarbons. So now let's talk about structures of hydrocarbons. So there are two main types of, well, we have three main types of structures actually. We have the straight chain, and you can see this straight chain in these three molecules I was talking about right here. So we have the straight chain structure. We also have something that's called a branch shaped structure. So now let's talk about branch shaped structures. Well, let's find some examples of it. So let me pull this diagram up right here. Enlarge this. Over here you can see we have a branch. So we can see our parent. Basically, this is called the parent molecule. So we can see our parent hydrocarbon, So this is our parent hydrocarbon, and as you can see, we have 5 carbons. And attached to this third carbon, over here, the middle carbon, we have another CH3 atom. A CH3, well, not a CH3 atom, a CH3 molecule, I would say. So a CH3 molecule is also called the methyl group. And most times to find the a group of something, to find the formula of a group, you would just subtract one hydrogen from the chemical formula. So obviously we can see methyl is derived from the word methane. So CH4 is a chemical formula, but the methyl group has a formula of CH3. And we can see a trend of how CH3 is one less hydrogen than the CH4. So a general rule is groups have one less hydrogen than its host or its main molecule, I would say. So naming this structure will be covered in the next video. But as you can see, there are multiple types of structures. There's a straight chain, where it's just a straight chain of continuous carbons attached to hydrogens. And also you can see that at the end of each straight chain hydrocarbon, we have CH3s. So we have a carbon surrounded by three hydrogens over here, and a carbon surrounded by three hydrogens over here. But in the middle, or not, it doesn't always have to be in the middle, but just like not including the ends, every molecule in the, or every molecule in the hydrocarbon will be CH2 for the most part, in straight chain molecules at least. So now let's move on to this last structure. We also have a cyclo structure. That's what they call it actually. Forgive me, they're actually called cyclic. So like a cycle. Cyclic structures. So by the name, you could tell that it's going to be in a cycle or a circle. So now let's get an example of a cyclic structure. So over here we have, One minute, let me just get this image. So over here we have cyclopropane. And as you can see, it has this ring structure or cyclostructure with the 3 carbon molecules in a circle-like structure. And although you might be thinking, well, it's actually a triangle. Well, its general form is that the carbons are in a continuous cycle, and the hydrogens are the outskirts of these carbons. So that's why it's called a cyclic structure. So this is called cyclopropane. And let's come up with some general rules for cyclic structures. So whenever we name a cyclic structure, we name the base molecule. We technically name the molecule as if it would be in its straight chain form. So technically, if we had CH6 in its straight chain form, it would be called propane. I mean C3H6 in its straight chain form, it would be called propane. But since it's in its cyclic form, we're gonna add a cyclo as its prefix. So cyclic structures have a prefix of cyclo. And same goes for anything. So we have butane, which is CH4, C4H10, and I use this rule right here. So 4 times 2 is 8, 8 plus 2 is 10, so yeah, C4H10. If I were to have a cyclic structure of butane, it would be called cyclobutane because of the cyclo prefix that we have to add before that molecule name. So now that we covered structures of potential structures of hydrocarbons, let's talk about the actual bonds that hydrocarbons can make. So hydrocarbons are split into, apart from their structures, they're actually split based on multiple criteria, but one criteria that they're split upon is how many double, triple, or single bonds they have. So let's say we have CH4, or let's take ethane for example. So let me draw ethane again right here. So as we can see, ethane has all single bonds. Therefore, it's called an alkane. So an alkane is essentially the most efficient form of uh, a hydrocarbon. And I'm saying most efficient because it's the best, or it's the only form where it contains only single bonds. And since it contains only single bonds, it can contain the most amount of hydrogens as possible. So we have alkane, we have ethane right now. Since it only has single bonds, it can contain as many hydrogens as possible. But say we change the carbon-carbon bond into a double bond, we can see that now carbon only has 2 valence electrons to share with. So now there's only 2 hydrogens that it can bond with instead of the 3 that we had with this ethane. And that's why alkanes are the most efficient, or they're the types of hydrocarbons that can store the most amount of hydrogens. And the general rule for alkanes is that they, as I said before, they store the most amount of hydrogens that is possible with the amount of carbons that's given. And they also have a suffix of ane. So as you can see, suffixes and prefixes are an important part in identifying types of hydrocarbons. So it's important to know all the suffixes and prefixes. And that brings me to the general, or the most common suffixes and prefixes. So first we have methane, or we have like meth and dash, so that's the prefix. And then we have eth. Oh, let me. We have eth, then we have pro. Then we have but. So these first 4, I would not expect you guys to know at the top of your head, because they're not common prefixes you would use to identify numbers. Normally they're like bi or di or tri or quad, but as you can see, that's not what it is. But now we have the normal ones, I would say. So we have pent to signify 5 carbons, and these prefixes are meant to signify the amount of carbons there are on the molecule. So then we have hex. I'll just name them all till 10. So we have sept. Let me put that right here. We have oct. Oops. Non. And we also have dec. So these are the prefixes you would use when naming hydrocarbons according to their carbons, according to the number of carbons. And keep in mind that even with the addition of these, you would still have to use like cyclo when you have a cyclic structure. And also we have alkane, so that the suffix of an alkane would be ane. And as you can see, that's evident over here. In the straight chain molecule, we have methane. It has a prefix of ane. You have ethane, prefix of ANE, and propane, which also has a prefix of ANE. So all alkanes have a prefix, have suffixes of suffixes of ANE. And suffixes are also known as saturated. So in this case, saturated is known as the most amount of hydrogens one hydrocarbon could store. So since hydrocarbons are the most, alkanes are the most efficient hydrocarbons when coming to storing hydrogens, you could say that alkanes are known as saturated molecules. So let me also write that they're saturated. So these are the things you need to keep in mind. So that it's saturated. Alkanes also only form. They only have single bonds, and they have a suffix of ANE. Now let's move on to alkenes. So over here I have made an example. I already made an example of an alkene. And an alkene is any hydrocarbon that has at least one, or let me change it over here. So an alkene is a molecule, hydrocarbon that has at least one double bond. So this is an alkene because it has a double bond right here. And also keep in mind that the double bonds can only form between carbons. Since hydrogens do not have the amount of electrons to have a double bond, the only way you can form a double bond is with other carbons. So carbon to carbon bonds can be double bonds. So at least one double bond. And alkenes, since they're not the most efficient, or they can't store the most amount of hydrocarbons based on that one single double bond, they're called as unsaturated hydrocarbons. So unsaturated, basically the opposite of saturated. And alkenes end with the suffix of ENE. So you can also see the significance of suffixes and prefixes again. And the name of this molecule is ethene because this hydrocarbon has two carbons. So to identify the name, we don't care about how many hydrogens there are. We only care about the amount of carbons. So regardless of how many hydrogens there are, if there are two carbons, the molecule will always have ethene, will always have like the prefix of ETH in the name. So now we covered double bonds. Now let's talk about triple bonds. So let's draw what this with a triple bond would have. So now we have a triple bond. So three of carbon's valence electrons are paired with the three other valence electrons in the other carbon. So we know that there's only one valence electron left, ready to pair. So that valence electron would go to the hydrogen. So these would both go to hydrogens. So now we have C2H2. And now you can see that this formula doesn't work because we have this C2H2. And also, this type of molecule is called an alkyne. And it has a suffix of YNE. It also has to have at least one triple bond to be categorized as an alkyne. And it is also unsaturated. You could also say that alkynes are the strongest type of hydrocarbons there are. And that's because of this triple bond. Since it has a triple bond, it's going to be really bonded with this other carbon. Therefore, the dissociation energy, bond dissociation energy, or the amount of energy it takes to break that bond, is a lot stronger than it's a lot more than it would be for an ethene or for an alkene or an alkane. So I guess the perks of being an alkyne, even though it's unsaturated and does not have as many hydrocarbons as a alkane, it's still a lot stronger than a normal alkane because it has this triple bond. Same thing goes for alkene as well. So now we can see these three types of hydrocarbons, and it's evident that there are multiple ways to classify hydrocarbons, and for that reason it's very important to keep these suffixes and prefixes and suffixes to keep track of everything, because who knows, if you don't have one of those, you might mistake these hydrocarbons as something else. So the next video will be talking about isomers and the significance of isomers in hydrocarbons. So it will be a detailed explanation, and we're also going to be talking about why certain molecules such as methane and methine can exist. So stay tuned for that video, and if you guys enjoyed this video, please like and comment, and if you guys have any suggestions, just put that in the comments as well, and subscribe for more content. Thank you.